G'day. If you're watching this, pretty fair chance you've got one of these Dometic RMD-8551 fridges. Or maybe it's brother or sister, the 8555. Both the same fridge. One's just an automatic energy selector and the other one's manual. This is the manual version, the 8551. And since I bought this 2014 build Caravan in January this year, this has been problematic. It doesn't work as it should, and it was getting to the point where I had to look at what I was going to do, because I'm going to do a trip to WA and I'm going up north and I want a fridge that works properly in hot weather. This doesn't do it. So with the price tag of around a bit under $2,000 to $3,000 to buy a new one of these fridges, and duly skeptical at this stage about whether or not I would be prepared to do that and buy another absorption fridge or move to a compressor fridge, and not only the cost of the fridge but the upscaling of the solar and DC to accommodate the additional power that's required to run a compressor fridge, I thought I'd better have a good look into this thing and see if I can sort it out, because I don't believe there's anything wrong with these fridges. They've been around a long time. They do, you know, people do have these and they work fine. Others, and there's been quite a few others, but the voices are always louder, or the ones that don't work, have had a lot of problems with them. So I investigated it on the net, had a look at the forums, and the anecdotal evidence is there's an issue with these fridges, which the manufacturer appears to have addressed on a couple of occasions, and it's rectified it. Now, so that's a manufacturing issue with this particular fridge, and that's certainly the case with this one. But before I look at that, let's have a look at how it's installed in the Caravan, because that's another failing, is the Caravan manufacturers do not follow the recommendations from Dometic, etc., on how it should be installed. So let's have a look at this one, see how it's installed, insulation, baffles, fans, etc., and what I did to fix those issues first while I was waiting for what I needed to fix this fridge, the actual fridge itself. So I'll have a look at that second. So first off, let's have a look and see how the fridge is installed in the van, and then we'll move on to the fridge itself. So let's take a look at the back of the fridge. Vents, insulation, etc. So this is an Evernew Caravan, and on here we've got quite a large vent. It's about 500 millimeters wide. It's at least 400 high, maybe a bit more, and the top vent is the same. As I say, seems to be peculiar to Evernew that they use these, and good on them, they've done it properly, because one of the things that these vents do is give very good ventilation, because they hinge open. So when you get where you're going, you just simply hinge it open like so. As you can see, there's a little arm here with a knob on it, and you just prop those open like that. Keeps the sun off the back of the thing, but it provides excellent airflow. I don't know why other caravan manufacturers don't do the same thing. This is just the best thing ever. Right, so that's one thing they did good. So when we get up and have a look inside here, you can see I've got a little plate here, but behind that is R2.5 or R3 insulation, which I bought on a roll. It's about 600 wide roll. The fridge is about 500 and something, so it's good. It goes just past the end of the fridge, and I've just put metal plates to cover over the end of it. Down the side here, there's insulation pushed into the voids, because the air would just pass up through there. The air will take the path of least resistance always. So you have to close off any other portal, if you like, from the bottom vent to the top vent. So now this is forced to go through this heatsink. That is the only path, because the other thing I've done is put this baffle in here. In this van, the distance between the back of these heat sinks and the back wall was 140 millimeters. That's way in excess of the Dometic's recommendation, and anytime you got up here and checked it, there was just air coming up I mean, the heat creates an effect here, but it wasn't going through here. It was just simply passing up through here. It was coming up the sides, and if you put fans on it, the fans do exactly the same thing. It rushes air up here, up there, and that has no great impact on, it doesn't have a lot of impact on effectively cooling the fridge. You'll also notice that this is tucked underneath this back of this cabinet. This is the cabinet above the fridge. I had to put a baffle in here because that was a void, about an inch or 20 or 30 millimeters, about 30 millimeters gap between the top of the fridge and the floor of the cabinet. I've packed that now with the insulation material, and I've put a baffle in under here. So there's no opportunity now for this hot air to get trapped in above there, because that affects the fridge's cooling performance, because it's pulling your freezer temperature down. So that's as good as I could get. This actually should be sitting higher. At this point, there should be a baffle coming up at an angle to allow that trapped air to get forced out through here. This vent is placed pretty much correctly, which so many aren't. I've seen quite a lot of vents where they're sitting down here, and that's completely ineffective because the hot air radiates up from here and it gets trapped in this space in here. The whole point is to make the air come through here and out. So vents down here, particularly small vents, are not going to work. When you're driving and these vents are shut, this void up in here traps hot air, and the air can't escape. So I've fitted a fan up in here now that only comes on when 12 volts is present from the vehicle to suck air out. Now, once again, in the manufacture of this fan, they fitted a probably 150 millimeter pipe, which is really quite inadequate for, considering it's got fly wire mesh etc in there. It's completely inadequate to vent this space with this size fridge. It's probably okay for a little 80 litre, 90 litre, but not for a 190 litre fridge or whatever they are. So that's this. This is just a prototype, but anyway, I'm going to see how it goes. I think that'll be quite effective in removing that hot air, because one of the problems when this vent's shut and you're travelling, you've got air just coming across here and coming across here. Now, there's no airflow top to bottom really happening here, because you've sort of got negative pressure across both of these, which creates just probably no airflow inside. The fact that there's heat in there is barely going to make any difference. What's more, the trapped heat has difficulty coming out up there. So without something to force air out through the top, this is not going to be very effective. And I've seen that deteriorate rapidly when I'm driving along. I've seen leaving somewhere with my fridge at 3 and arriving and it's at 10, because the whole thing's been completely ineffective. Not the case now. Right, so that was that. So as I said, I've got insulation down the sides. I've completely blocked it off, but I've also insulated the back wall here. We've got insulation in behind this baffle, right across, all the way down the wall, right through to underneath here. So that will stop radiated heat getting to the back of the fridge, and this is particularly important for hot weather. All right. So what have we done here? Just trying to grab the phone here the right way. Can't find my camera, so I'm using the phone. In the back here, now I read on Caravaners Forum where some people had done this. I've completely lagged the boiler in here with, again, this insulation. I've put, this is wrapped around, this is a 80, 100 millimeter diameter chimney, if you like, boiler, which is already insulated and it has an outer metal jacket. But if you ever get here when this is running and feel this, the amount of heat pouring out of this thing is quite incredible. It's very, it gets very warm. It also radiates that heat into the back of the fridge. So here I've fitted a heat shield material. It's an adhesive heat shield material used in automotive applications to stop radiated heat from the mufflers going through and heating the floor of the car, etc. So I've cut that into a strip and tucked it in behind the chimney because I can't get insulation in there, the gap's too small. So that runs the full height of this this boiler. Then that is then completely wrapped in the insulation material, this stuff. And then I made a shield up for that holds all that in place, and that fully insulates that chimney. There's also a bottom plate here just to hold it up so it can't shake out. This retains very importantly a significant amount of heat in here. I think the benefit of this has improved my startup time, the response time when the fridge thermostat cuts in. It seems to be much quicker now to take effect, and as I say, it seems to have considerably improved the startup time for the fridge. It gets down to temperature much quicker. Also, this fridge comes with a fan. A second fan is fitted. I fitted a second fan, sorry, because the later models had 2 fans. Subsequently, I don't think that's necessary. This one fan would have been fine. The fan is activated by sensing the temperature on this pipe, and that's purely just a method of estimating how hot the system is, I think, and it gives it just a cut-in point, so that will start the fans running. Here I fitted a speed control because I found that if these fans run at full speed, these 12-volt fans, and they run at full speed, it has a detrimental effect to the fridge. It actually goes backwards because it's stripping too much heat out of the system. It's a delicate balance. You know, on a hot day you need the fans to extract the heat to maintain a certain temperature, but on a cooler day you don't want these fans cooling it down. And when I say cooler day, I mean up to 30 degrees. But even at over 30 now, these fans rarely run. Since I've fixed it, I don't even need it, and this speed control is set to absolute minimum, so you can't even hear them going, and they're barely making any air movement. It's so effective. So that's all of those changes there, I think, on the back of the fridge. And I'm pretty sure, you know, all these things are collectively provide significant improvement, and I now think this fridge probably operates very well right up into the high 30 degrees, because I've already seen it running at 33 degrees. I started it from hot at 33 degrees, and in 5 hours, it was 4 or 5 hours, it was completely down to working temperature. And I've never seen that before. So, and a lot of that's to do with doing this, and insulating certainly is to retaining and maintaining your fridge temperature. The insulation is important. The creating the right ventilation for the heatsink, and getting your airflow correct, and making sure that the air goes through those fins is critically important. So collectively, these changes have very significant effects on your fridge's performance. Okay, so we've covered insulation, baffles, venting, and fans, and lagging the boiler. Now, all these are critically important, and they should be done to all 3-way fridges. They should all be installed correctly, and if you do that, even if it appears to be working properly, it will work much better. Let's have a look at this RMD-8551 and investigate what went wrong when they assembled these fridges, and what I've done to fix it. And you can probably apply that. If you've got one of these fridges, I would certainly be having a good close look at this, because it seems like all of these fridges possibly not, but apparently a lot of these fridges suffered from this problem. So something went wrong. Maybe the apprentice was doing it on the day or for the week or for the first 200 fridges before they discovered the mistake they made. But whatever it was, they should have fixed it, and they didn't. So let's have a look at it. So this is the inside of the freezer first. You can see at the back here we've got a heat sink. Well, in electronics that's what it's called, but it's the same thing. Fridge is a heat pump, collects stuff in here that is at a higher temperature than the refrigerant that's running in behind here. This refrigerant cools this element down, and the warmer temperatures in here are then chilled by that. Anyway, pumps the heat out into the refrigerant gas that's run through the fridge. So this is the key to getting the fridge getting cold. This is key. It must work properly. Guess what? It doesn't in this fridge, because it wasn't assembled properly when they put it together. So we'll have a look at that in a second. And there's the same thing in here in the freezer. In the fridge. There's the same type of unit in the back here, also not done properly. So I'll just show you these when I pull them out, and you can see how they got it wrong. Okay, well, here we are. I've removed the screws of this finned heat sink or cold sink arrangement, and I started cleaning the back. I was just for demonstration showing you how that sat there. I started cleaning the back of this thing to get all the old mastic, thermal mastic off it. So it comes out. I've mixed some electronics heatsink with this. My first attempt was to try and make what was bad a little bit better, but that was pretty ineffective with just normal heatsink compound used in electronics, but it didn't work. So this mastic stuff's I don't think this is really quite gooey, and I think it's dried out, and I did see somewhere it should be replaced every 3 or 4 years or something. This all has to be pretty much removed, so I'll dig out most of this old mastic. This part here is a problem, because that when I removed this heatsink originally, so this is sitting the way it goes. A large portion of this had no contact. I'm not sure if it was this bit or this bit down here, but even that bottom part, which lines up with here, was not making contact with the heatsink, so there was no transfer of heat coming, from the fridge back into heat pump. So, or transfer of cold, if you like, from the pipe to this finned arrangement to keep the fridge cool. This section here, I think, wasn't making contact. The mastic was not, was completely inconsistent. So there were parts where it was clearly very sparsely populated, and the problem with that, of course, is that we've got probably a 20 millimeter pipe here, 3/4 of an inch, if you like, or something of that order, and that's mating to a flat surface. So the physical contact area between these two metal surfaces is minuscule. It's millimeters, probably 1 millimeter, or a 32nd of an inch is all the physical contact is. So this mastic's purpose, it has to have a good heat transfer rate, which they do in watts per centimetre or something, or micrometre or something like that. And if it deteriorates, then the transfer it does not occur. You lose your efficiency. What I saw with the fridge was, while the freezer would get to -20, this fridge was, you know, quite often 5, 6 degrees, even after going for a couple of days. And when I did this, it certainly improved it. But that's in conjunction with all those other things that I've done. So this is the last bit to do now, and I think I'm going to reapply mastic all the way through here, and I'll probably do the freezer as well, even though it seems to be working okay. But it just seemed this was done by Dometic as a result of complaints about this fridge. They did a couple of fridges at Jayco, and one of the things they did was pull this mastic out and reapply it, apparently, and that improved. A couple of people reported that made a huge difference to the performance, you know, to the performance of the fridge. Anyway, I'll get on with it. I've got to clean all this down, get all the mastic off, and then give it a clean with isopropyl alcohol or methylated spirits or some sort of solvent stuff, and then I'll start on the reapplication of new stuff. All right, there we are. I've cleaned that about as good as I can, I reckon. And probably I've exposed, you know, this whole front part of the pipe is now ready to be re-mastic, or ready for application of the thermal compound. So I've completely cleaned the back. Now that all came off with paper towel to remove the bulk of it, and then when I was down to the dregs, I just cleaned it off with methylated spirits, but an isopropyl alcohol type solvent of some kind. So that worked very well for removing the last of it, and gives me nice clean surfaces to work with now. So next job is to reapply the thermal compound, and then that'll be the fridge done, and then I'll move on to the freezer. All right, so I've just started reapplying. So the stuff I'm using is this here. I got this from Amazon. It's a little bit expensive, but this is the stuff they use on some of the American ones. You know, it was a bit difficult to find anything locally, and this price wasn't too bad compared to probably what you'd pay here. So yeah, heat conducting thermomastic. And interesting thing is that the consistency of this stuff is quite a bit more fluid than what I took off. It was the consistency of old dry putty, and you know, cracks in it and stuff, which would indicate, you would think, that probably doesn't transfer the heat very well. But so it's a mastic so that it's solid enough to stay on that vertical surface, but you know, can't be any more liquid than that. So it's certainly much more. It's very similar to toothpaste, I suppose. No, it's a bit more solid than toothpaste. Anyway, I'll keep going and get this all on. All right, there it is. It's all on. So normally, with a heatsink compound where you've got two flat surfaces, less is better. But given this is a round surface meeting a flat surface, I've gone for more, so that as I put the heatsink on, it will flatten that, give us a greater contact area, and hopefully transfer, you know, better from the curved sections either side of this very small center point of the hose that makes contact with the heatsink. So I'll stick the heatsink on. Well, I call it a heatsink. I suppose it is the finned arrangement, and see what, and then I'll pull it off and see what it looks like, I think. Probably the wrong way. Okay, here's the freezer. So I've added stuff to this. Again, I think I only had partial coverage on this this thing originally. There was gaps along here. I've put this grey stuff on. This part over here was completely. Get this thing out. I think this part here was quite Actually, the pipe came over the edge of this little step. You can see there's a little step here, and was actually not contacting anything at that point. So I added this piece of aluminium on here, and I've got a thermal compound between those two flat surfaces there to transfer some of that cold. So I'm working on the premise that every little bit is important in one of these fridges. So these sort of gaps you get here, and there was gaps up here, you know, will end up with a poor output as far as the fridge goes. Righto, so going to do the same again. Pull all the mastic off the heatsink and put all the old stuff and the grey stuff I added. I'll get onto it. Okay, there we are, all cleaned off. So the yeah, so I think it's important to get that fairly clean so you get maximum transfer. Check, it'll be worthwhile checking that this foam, the styrene that's blown in here, is not over the top of the pipe, which it was up a little bit on the sides there, but not on the top. But anyway, always worth checking. Yeah, so that's it, I think. It's all looking pretty good. And I've got, you know, the whole top half of the pipe basically is exposed, the part, you know, to obtain maximum transfer. So I'll glue it all up and get it back together. All right, here we go. It's on. Hopefully, well, the freezer was good anyway. It was pretty good, so probably just pick it up a little bit. We'll see how it goes. Okay, here it is, all back in. So it's important you do these screws up twice. Go around, do them all up, and then go around again 2 or 3 times, because as the heatsink beds into the mastic, it just the screws become a little bit loose. Now, don't over tighten them. I'm sure there's some specific tension you're supposed to put on them, but you know, just do them up so they're nice and firm. And but do them all twice. So I've done that with all of these, and you do notice that you can get an extra quarter or half a turn out of the screws the second time around. Most of them, not all of them, but anyway, she's right to go. So I'll be switching on and see how it goes. And fridge done. Last thing I did to this was I've put a fan in here. Now in this fridge there's a little couple of little plastic slots that are created on either side here. This is about 330 millimeters wide, so it's actually brilliant. So I made up this is just a sort of fabricated out of that 1/2 mil aluminium, and on this side over here I've put a 60 millimeter 12 volt fan. It's a little small thing, it's not very big. Bring this forward. So that's it there. A little 12 volt 0.14 amp fan, 60 millimeters, and that moves a very small amount of air, and that is ideal. You do not want a lot of air moving in here, and by making this shape, it's open at the back here. There's a gap there. Well, not much. I couldn't do much about this gap that's here, but that's actually not bad. It leaks a little bit out that comes down along the door, which is ideal. This creates a waterfall of air, very slow waterfall of air across these fins, and that drops down and circulates cold air in the fridge, and that actually does a really good job. It is beneficial. You do not want 2 big 80 millimeter fans in here attached to that heatsink, which I've seen some kits do that. Totally unnecessary. You don't want to move huge volumes there. You just want enough to stir the air up and perhaps get a bit better equal distribution in the fridge. All right, so all of those things combined, this fridge rocks. It is going brilliantly. I have no complaints. I am now pretty satisfied that I've started this in 33-degree heat. It's pulled down. When I was doing the fan, it was quite hot that day. It was over 30, and I had that door open for 5 minutes while I measured up to make that several minutes. And then I opened it again when I bent up the aluminium for it. And then I had this door wide open like this. Tried that thing on it, adjusted it a little bit, slid it back in again, did some little measurements, and then sort of took it away and did some more work on it for this thing. And then closed that door, and within 30 minutes the temperature was back to where it was. So that sort of recovery I have not seen before. That's brilliant. And then I came back and did that again, and the same thing happened the second time. And to say, it was 30 degrees that day, so quite warm in here. And that was in the middle of the afternoon. Part of that was to test to see what its recovery was like. Really good. So the freezer, I see within, I've got a temperature loggers in here, little temperature sensors, one on the fridge, one on the freezer. And they come up on this display here, which is difficult to see, but so freezer and fridge. I see this, this is down from 30 degrees, it was down to 10 degrees within 15 minutes. And within, so the freezer comes down quickly first. This will, you'll always see your freezer come down quickly, and then the fridge trails behind it. Once this gets down to around about the zeros, then the fridge starts cooling down. Much bigger area to cool, of course, so your freezer's much more responsive. And as I say, within this whole fridge is now down to working temperature in 5 hours. I used to have to leave that all night. That's a big fridge too, so I could get something like 8 or 10 hours for my old 90 litre fridge to get to temperature, but this, and I had insulated it and done a bit of stuff to it, but yeah, this is working brilliantly. Absolutely, this has fixed this problem with this fridge. This fridge now operates the way you would expect it to work, and I suspect it will now operate as a tropical rated fridge, because I don't think there's any difference between subtropical and tropical, apart from perhaps the heater elements and the gas jet burner. I think maybe they're the things that differentiate it, because all they're doing is moving its upper and lower temperatures up and down in the scale. A subtropical fridge runs from I think it's from 10 to 30 or 12 to 30 or 8, something like that. I don't know, something in the teens to 36. A normal fridge operates something from 10 to 20 something, 28, and a tropical rated fridge runs from 36 down to a minimum of 18 is its operating range. So they're just moving the range around. They're doing that by how big the heater elements are and how much heat it generates. The fridge itself, there's no difference in the refrigeration plant. So because they're trying to adjust the low temperature, the lowest temperature to work at in case you're somewhere cold. Well, again, and there's nowhere in Australia where that's really relevant for us. We should have tropical rated fridges always. I'd never had no problems with a tropical rated fridge. The last fridge I had was tropical rated. It was fine in Tassie at 0, worked perfectly. All right, fridge done. That's it. Works great. Do this and you will have a perfectly good RMD-8551. You do not need to go to a compressor fridge. Works great.